question is very interesting, and it's in terms of the integrations, in terms of substitution. So I think that it's very good if I were to share with you. And therefore, here's the question: dy dx plus dun dun is equals to 0, right? So what is this thing, and how do we know that it's in terms of substitution? The first thing first is the number of degree, number of order, I would say. Alright, each term, this term is first order because it's just x itself. This is also first order, first order, first order, first order, first order. So everything is first order, and therefore we can see that some sort we can actually, group things together. Alright, you may find that you want to group this thing together, but think again. This thing is in fact 2 times x minus 2y. Alright, this thing is 2 times of this. So what we can do is just to sub it in. Alright, and therefore we can write u is equals to x minus 2y. So we are talking about substitution now, right? And therefore if I were to substitute this, I would have dy dx plus, right, in terms of, instead of x minus 2y, I write u, right? So I have u over 2u, right, u plus 5, 2u plus 5, right? And still this is something really tricky, right? This is still something really tricky. And what we can do, right? But think again, we still have dy dx to solve, right? Normally, substitution, once you sub in u, next step is to sub in dy dx as something, correct? And therefore, you just differentiate, right, in terms of y and x. So y is, because this is in terms of dy, right? So you're gonna write in your equations in terms of y using this equation, and therefore u is equals to x minus 2y, alright, and that 2y is equals to x minus u. If you just divide everything by 2, you have this thing. So y is equals to x minus u over 2. Alright, it's pretty clear. I'm just taking what we have just substituted, our choice of substitution, and then I'll just plug it in into this equation, solve for in terms of y, and then I just differentiate now, right? I'm trying to replace this term in terms of x and u. Sorry. Yeah, and therefore if I were to differentiate, or maybe I just write it like this, wouldn't it be better? So if it's dy dx, what I have is x over 2. If you differentiate, you are just getting the coefficient half, right? Half x, if you differentiate, you get x. You get half. What the hell am I talking? Anyway, and then minus u over 2, right? You're going to differentiate in terms of x. So how do you do this, right? It's just simply half, and then you just differentiate u, right? You just put it as du dx, and that's it. Factorize out the half, you would have 1 minus du dx. Ding ding. You have something, right? Therefore, I'll just sub in this thing in terms of dy dx. Alright? So just allow me to rewrite things in a more neater way. And therefore, this one, dy dx is equals to this thing over here, which is what we have just derived. You find it familiar, right? We are just repeating what we have just done in the previous video on substitution method. Alright, if you haven't watched it, I would suggest you go and watch it. Yeah. And therefore, let's continue. So I'll just bring this term to the other side. Right? And therefore, if I were to bring this to the other side, I think I'll just do it together with you, at least you'll be kind of like, interactive. I don't know why am I saying this as interactive, but yeah. So it's this. right? So it's still kind of little weird, right? How do I, rearrange this thing, right? It's pretty weird. Let's write half minus half du dx. I shouldn't have factorized out. I don't know why. Yeah, but I'll just have minus u minus 5 2u plus 5, right? And now that's things start to get a little more tricky, or maybe I shouldn't do that, just leave it as that. While I bring this half, alright, I bring this over here. So I'm just, what am I doing? I should have, sorry, my fault. I don't know what the hell am I doing. Alright, I'll just bring this half, this 2 upwards to this side. Okay? So if I were to do that, I'll have this form, right? And then now if I were to bring this 1 over to the other side, alright, if I were to bring this like that, then this will become minus. So now I'll just bring this minus to the other side also. Alright, so I'll just bring everything in terms of minus, right? And therefore if you minus 2, you have plus, minus 1, you have plus, and right, therefore this is plus 2 plus 1. Alright, just to write things neat, this is it. So now the trickiest part come in. How do you solve for the integration? Right, this is real hell of a messy stuff. Right, how? So fear not, this is just simply algebra, but then requires certain algebra cheat code. Alright, requires certain algebra cheat code, but what I want to do is just multiply in all this 2 first. Right, if I have to multiply in, I have 2u plus 10. I change this 1 is equals to becoming 2u plus 5 over 2u plus 5. This is simply equals to 1. I'm just rewriting it as that manner. So right, so therefore I have plus, alright, this is plus 2u plus 5 over everything 2u plus 5. Alright, I hope that's clear. I just simply rewrite this as 2u plus 5, and then just bring this and add it together with this term, this term over here. So I keep all the denominator the same. Hope that this is pretty clear for you. I didn't, make things complicated. And therefore we have this thing over here. And then you just sum it out together. We have 4u plus 15, 2u plus 5. Alright, it's equals to du dx. Now I'm gonna group all that u in one side, x in one side. So what I have, it's 2u plus 5. I'll just bring all this up, bring all this down, and then just simply the algebra method. Right, is equals to dx. Shouldn't have done that, but du is equals to dx. So I'm just bringing dx up there. I think you get what I mean. I'm just simply doing algebra. Alright, so now how do I somewhat integrate this thing, right? I said this before, when you see du dx like this, definitely you know that time to integrate, that thing. So therefore time to integrate. And how do you integrate this thing? This definitely becomes x. But what the hell is this thing? I don't know, right? Then this talks about the cheat code of algebra, right? So now I'm gonna introduce you with a new cheat code, algebraic cheat code. So what is this algebraic cheat code? Although these alphabets may be intimidating, alright, just take a look. hx is just some somewhat coefficient of x. L is some coefficient of L. Y, some coefficient of y, and then these are all the remainders. So what we can solve is to solve by multiplying the whole equation by kx plus gy. So if I were to do that, I would have a kx plus gy plus b is equals to hx plus ly. And then we have akx plus agy plus b is equals to hx plus ly. Alright, and then okay, sorry, pretend I never say anything about this. Using this I already mess up. Anyway, just let's just solve for this. What the fuck am I doing? Alright, so imagine I have a plus b, okay? I take in the denominator over here, 4u plus 15. But before giving out the answer, I should thanks my friend and some internet connections. So yeah, it's pretty cool. Without them, I can't get this answer. So yeah, let's continue. I can rewrite as this, right? Can rewrite this term in terms of this term. Alright? And to solve, I will just multiply the whole equation by 4u plus 15. Okay? If I were to do that, okay, 4u plus 15, okay, I just play this out. So I would have 4u plus 15, a plus b is equals to 2 plus 5. In other words, what have I just done is simply to multiply the whole thing by 4u plus 15. So this is 4u plus 15, 4u plus 15, 4u plus 15. Okay, so I'll just cancel them each other, cancel, and I have 4ua plus 15a, I'm just multiplying in, plus b is equals to 2u plus 15. Alright, and from here you can see that I can group in terms of the coefficients, right? 4au plus ka plus b. Is this k? No, this is not k, this is 15a plus b. Alright, is equals to 2u plus 15. From here, we know that in terms of coefficient u and this u, alright, this u and this u, 4au is equals to 2u, right? And therefore a is equals to half. So now we can solve for b, right? And therefore b is just simply, if 15 times half, we will have 7.5, right? Because this is still 15, so b is 7.5. So we know that b is equals to 7.5. So if I were to rearrange back, alright, I would have half plus 7.5, 4u plus 15. So I'm purely replacing this as this one. Alright, and you can just simply integrate already, which is pretty much easier. And if you were to integrate, you would have half u plus 7.5 ln 4u plus 15 is equals to x plus c. Alright, and this is the answer, where u is equals to x minus 2y. Equals to x minus 2y. Alright, because u is in terms of x and y, if you want to rearrange in terms of at first was dy dx, right? In terms of y, if you want to rearrange y in terms of x, it's gonna be very tedious. So you can just leave the answer like that, and it shall be fine. Because for me, it's really a hell of algebra, and therefore this should suffice. And I don't think if you sub u is equals to this thing, you will get some answer. I don't know whether will you get y is equals to all about x plus 3x all in terms of x. I don't think so. You may have something different. So I think we just get it over here, and this is the answer. But the takeaway is that you need to really know how to identify whether it is a substitution method. Alright, if they are all the terms are first order, right, all these variables are first order or same order, then you know that it's substitution. And therefore when you substitute, you're going to substitute which are the things that is common, and then you just substitute. And once you substitute already, the rearranging part, and make sure that you know that when you differentiate this u is equals to x minus 2y, you're trying to find something to replace this thing. So you're going to write in terms of y in this case. So you don't need to take a look on what is this term over here. If this is y, then in terms of y. If this is dx over dy, then it's in terms of x itself. Right, so you have to be very careful. And the next part is when you differentiate in terms of product rule, which is what we have done just now. You just click it back to thing. For example, if you want to differentiate u in terms of dx, right? Let's say for example d dx, you don't differentiate straight away, it becomes 0. It is actually du dx, right? So these are the little small things that I believe is very important, because this concept is very important. In the long run, you may forget it, and then you may accidentally forget, and then you just differentiate wrongly. And the last one is this one. Alright, if you have this type of algebra, you can just rearrange as what we have just said earlier, and then you just solve it up. So I think this is a very good example in terms of substitution method. Alright, and that's the answer, where u is equals to this one, and it shall be fine. Alright, and I shall see you soon in other stuffs. Good luck.